EeSeLe 727.
So you have to excite. There is a different ways to excite it. A delay system is easy. You can just select at that frequency and it will show that configuration and space which it will take. Configuration मतलब क्या shape लेगा. For example, अभी इस केस में क्या हुआ कि अभी इस केस में क्या हुआ कि
हमें तो वो सब भी नहीं
तो देखो तो
और पेपर
वो बच्चे का जाता है सब फेल हो गए सब फेल हो गए हैं
अभी भी खाता हूँ क्यों भाई आज मेरा तो दुनिया क्या काम कैसे क्लास न्यूमेरिकल से करा है क्लास में एक न्यूमेरिकल करा था फिर दूसरा प्रीवियस यूज करा है इनको पढ़ा रहे कैंडिडेट कैसे दैट इज नॉट अ वेरी जानते हैं उसको भी सुपर दे रहे हैं
वो सब बेसिक इलेक्ट्रिकल ही है, कोई हाई नहीं है, वो हाई लग रहा है।
उधर भाइयों तो कर लिया
बेसिक एप्लीकेशन भी है पर वो जा रहे हैं
वो गेट का एक नंबर है, एक नंबर दो नंबर है।
हमारे गेट में शूटिंग है
ये नहीं है सीधा करके फार्मूला पीछे बैठा है
So I will be taking care about this environment part. So Professor Satya, I think he has taken care of ecology part, And where did he leave you? I guess that nutrient cycle and this pollution part. So environment part that we will discuss that mostly this pollution part, environment, because ecology, when it was discussed, more or less you get familiar with how it interacts with the environment. Right? That was one of the part of the ecology. That what are the biotic and abiotic factors that, right, and that how it interacts with the environment. Of course, you have to discuss it, right? Otherwise, you cannot avoid it, right? So now this pollution, right? So pollution part means that it's a human intervention, right? Which is now becoming more and more important, right? Because otherwise the human part, that was one of the biotic factor of your ecological activities. Okay. So now, however, their activities, which is arguably, may not be arguably now, but even like maybe 20-25 years back also, arguably changing the different amount of the substance, and it is disturbing the equilibrium of the system. That's what we can tell, and that is what we can tell, and that is having adverse effects on themselves as the ecological other components as well as on themselves. And in fact, when it started affecting themselves, therefore this awareness for this pollution comes into the picture. That is how it is always. For say for your air pollution, your water pollution, your soil pollution, everywhere it is like that. Unless there is a death, which involves death means like a large amount of death, then only these things has actually come into the picture. That thinking about implementing laws and the regulations, right? And it is just came maybe like a 60, 70s, means like another 50 years back, like that. Okay, not before that. Okay, so now when we are discussing this different, different substances are there, each is a natural substances, and there is some changing, highlighting the equilibrium, right? So then, of course, naturally comes that what are this natural cycles, right? Which is, I think, it has been discussed, right? Nutrient like carbon cycle, phosphorus cycle, right? And nitrogen cycle, of course. These things has been discussed in the class. So these are the more or less these are the cycles that you can identify. Hydrologic cycle and this water cycle, this carbon cycle, nitrogen cycle, phosphorus and sulfur. And because carbon, of course, organic, you are organic, right? Therefore, carbon is essential. And your nitrogen, sulfur, phosphorus, these are the things that there. You can see these even glucose and other protein molecules are there. These are the essential components for these nutrients also, right? And there are, of course, the other components are there, right? If you, I don't know if you remember these biology classes, right? They used to remember by a mnemonic. It's called C-Hopscan-Mac. So it is a C-H-O-S-C-A, and this is how it is used to remember this thing. Right, so hydrological cycle means that how the water, and you can see that these precipitations are how it is forming, right? So which is the transpirations from lands and evaporation from the inland waters, and maybe this also there is evapotranspirations that also has been discussed, right? Which is from this your plants that live that also comes into there, and there is these precipitations are there, and that's how which is on this water body directly, or there is on the land, and from there is a runoff is there, and therefore it goes to the water body, and at the well as well this your oceans, right? And there is a some of this part that can goes to the underground. Okay, so I mean, what is the important for the pollutions here, right? So this can actually carry the pollutants, right? Water, like water is of course essential for your daily activities. Your cleaning, you have to take it water because human body is like 70% water, and the other animals there. So for example, how the water pollution comes into the picture, right? So you are using one thing like the pesticides that has been used there, right? Which is like you have to use it in your crops, right? And so therefore these fertilizers that comes into the phosphorus part, right? Phosphorus you have to use it like that. Some this ammonia that you have to use it like that. This actually comes, and there is a huge amount. So all the things are not utilized completely, 100% not utilized by this crop. And there will be extra substances which will be washed off and it will come like that. So that is how it is water pollution. Some will also go for there is a inside and underground, right? Water. So these are the things we will be discussing. And of course, the other water pollutants are there. These are the things I am relating to your last classes, the nutrients, right? There are these pathogens are there, which is of course a large, the major substances for the water pollutants, right? So we will be discussing this in detail. What are the water pollutants are there? What are the effects on that? How the pollutants move, right? And one section of our this course will be dedicated to the underground water pollutions, how it moves. Okay, right? Then, so we'll come back to this part, of course, hydrological cycle, and that is the importance of hydrological cycle. This is your carbon cycle, right? It has been introduced, carbon cycle, and you know that how these carbon elements, right? Elements, this has been, it's not now creating or destroying. These are there actually. Whenever Earth forms, so therefore after that you have there is a amount which is fixed. You can consider it as fixed there, right? When there is an Earth formation, and these producers there is a part of this producers are there which can actually also create the fossil fuel, right? Fossil fuels are there, and from there this combustion is there. So combustion is directly combustion like that, and the fossil fuel combustion is there. I have not here very differently, I have not shown it here, or these books it is not shown here. So and from there when you are combusting, then it is goes to your CO2 reservoir, right? So carbon cycle when we are discussing, that is the one where CO etc. it is very small, of course it cannot be very large and you will die. So that the CO2 is the one which is there. CO2 for atmospheric, that is that, and there is a huge carbon components are there, which is in the carbonate rocks, right? But carbonate rocks, from there how it interacts with the atmosphere or the other components, that term over time is very small. So therefore you can more or less you can just ignore it here, right? So carbon cycle is there, your respirations are there, respirations, and this combustion. Respiration, there is a huge biotic components are there, everyone is respirating. So carbon cycle in fact like a photosynthesis, respirations. This would in fact can actually complete the carbon cycle. Fossil fuel combustion etc. How are they contributing? There are forest fires are there, right? So of course when a forest fire there, locally there could be, understand that carbon cycle, right? This cyclic process is going on there, and there are like some reservoirs there that I am going to show. Means that there are this much amount is there in the atmosphere, this much amount you are respirating, this much amount is actually in your body, carbon. And these are the things that this is called the equilibrium. You are actually sustaining, your environment is sustaining with that. So there is no problem in that. But of course there is a local fluctuations every day. And like a forest fire. Locally there is a huge forest fire which is like Australia, this happened a few years back I think. Right, so this kind locally you can quarter. The concentration is actually so small. So it was like considered it is okay, it is not. Even the deforestation also consider that it is may not that much affecting it. Whatever it is, the perturbation is so small. Right. But the thing is that, so these are like the natural solutions there. But the thing is that industrial emissions, population's growth also you have, that has been discussed also, right? Population, you see that this logistic curve, it has been following there. However, you see that human populations, logistic curve it is following, but there is a huge, human population is increasing and increasing there. And their demands are increasing. One is energy demands are increasing there, and therefore the other demands are increasing. Therefore, power plant, industrialization, etc., is there, right? And it is when people just realize that what it is emitting, the carbon dioxide, it is start emitting. Of course, the other part is there, SOx, NOx, etc., is there. But carbon dioxide is a major part which is emitting. So, up to some point, even it was argued that it is good. Carbon dioxide is important, right? It is a greenhouse gas actually. Because of this carbon dioxide, you are not living in the ice age, right? It is containing this temperature, it is holding your this thing. That's why Earth is actually habited there. If it is not there, actually, it will be so cold, it will be inhabited there. But later part, then started realizing that it is starting affected. Therefore, which I am saying this awareness didn't come even like 50, 60 years ago. That time also it was applicable. Of course, there is a stakes are people still also, right? There are stakes are there for people. So you see, this I think this Chapman book you have read, right? That you are familiar with this, right? So that this is has been done 1983 and some information from 1995. And you can see that what are the numbers are there. Atmospheric reserve is 760 into 10 to the power 50, 7 into 10 to the 7 gram, right? And fossil fuel, of course, the reserve is very high, carbon reserve, it is very high. In whatever form it is there, complex form it is there. How much they are contributing there, right? Every year, this number which has been circled or the other numbers, is that how much is it is contributing for. That is actually 5 into 10 to the power 15 gram per day, right? So this was like a 1985, and that mostly comes from your fossil fuel combustion. Now the thing is that with this part and that whenever it was formed, it was okay, it's all okay. In deforestation, it is 5, deforestation is 1 to 2 like that. So it was saying that it is may not be like a increasing much, but this is like an annual increase. You see that there is a 3. So it is a little bit alarming there, and this is how it has been with the collection of data. It has been there, and probably this book, when it was the data, it was like 2005 or 2005 it was taken, and that this was extrapolated, right? So you can see that same thing, that carbon output million tons. If you do this thing, that it is a coming like a 1980, you can see it is a 5,000, around 5,000. So 5,000 is that 70 that graph, right? So now that you started seeing that the greenhouse effect, right? So greenhouse effect is that gradually it is noticed that the average temperature is actually increasing, right? The thing is that average, which is like say 1 degree centigrade. Of course, 1 degree centigrade is very high. We are averaging it. So now, even after that, the argument what else can, that may not be greenhouse effect, but your urban this area is increasing. So it is actually increasing the heat component. That might be the one which is a polluting your data, you are interpreting is like that. So these are the arguments that are for a long time. This is arguments has been there. I guess so right now also it is there. But more or less many people there are more this people agree that this is there actually, and that is like air pollution. It is what is causing the greenhouse effect. Some of them actually very direct. For example, CFC, the effect of the CFC. The ozone layer, that how it is affecting the ozone layer. So therefore, this restriction has been done there. Okay. So so this greenhouse effect, you can see the carbon dioxide that is causing the 55%. The others are not that much, methane, etc. But methane turnover is actually very fast there. So therefore, it is there, but it converts into very fast. So therefore, that much not important. But carbon dioxide is which one is most important. And there are like this other. These pollutants are there. For example, this SO2 you can see that is causing the acid rain. That some part also, of course, the nitrogen dioxide also going to contribute there. And these CFCs, these are the things that are which actually the stratospheric, this ozone layer, that depletions cause there, right? And this methane NO2 that we will see later, that this actually creates with presence of the sunlight photochemical smokes. There are different other organic compounds it forms there. So it like forms a smoke. What you see, like in a winter time in the morning, what you see, that is the smoke there, and it has other health effects. Okay, adverse effects are there. So this is how these are the things. We will start air pollutions from. What are the criteria pollutants? That first we introduce this thing in details, as much details we want. Then after that, we'll see that what are the source of the pollution, right? Source of the pollution means that source of the pollution is like immobile and mobile. That is how we first divide it. So one is like your this transportation, all these vehicles are there, and other part is that your industry, that different plant. So where it is coming from, and we will be discussing some how to mitigate that. What are the technologies are there? Of course, laws, regulations, these are there. Means that you just avoid the source itself. There. Other thing is that you can have some technologies which can, in fact, because of course you cannot avoid the full technology, right? All industry you cannot avoid that. So therefore, like an emission is there. So emission regulations, etc., is there. But other thing is that you can use some technologies that we'll be also discussing, which can reduce the emission, the criteria pollutants in the emitted fluid. Okay. Right, so one of the part that comes from this is nitrogen cycle. So a nitrogen cycle, that also we have discussed that. So when nitrogen cycle for ecological part, therefore this right hand part, that is okay actually, right? So your this ammonifications and the nitrogen fixations is there, and how it is coming into the picture. But there is again, because of this, this your factories, these things are there, so therefore this will contribute to this pollution part. Similarly, for the sulfur cycle, sulfur is some part is there as a basic constituent of the protein in plants and animals, and again there is these organic matters are there. In the organic matter, the sulfurs are there. For example, in the coal also, like there is a sulfur, some sulfur amount can be present there. And because of this combustion cycle, this actually goes to the atmosphere and it causes different problems. Phosphorus cycle. Phosphorus is also another important part. And it is pretty simple, right? You see that inorganic, this heat is converted into organic thing, and it goes to the land, and it directly it just there, and decomposer again take care, and it makes this. Yeah. So this is what actually phosphorus cycle. But there is this from the soil particles. So the phosphorus is a phosphate actually. That's how it is there. H2PO4 that by phosphate, it's like that. And this some part that actually comes to the water bodies, right? So this phosphorus, this one actually takes a major role in water pollution, right? And because this is called the eutrophication. So phosphorus, you are familiar with about eutrophication, right? So I am saying that phosphorus, particularly this phosphorus pollution. So this is one of the we can consider as a nutrient, and it's like a direct effect of the nutrient pollution, right? So what is nutrient pollution? Means that the nutrients is essential. When I say nutrient, it's of course essential for your body. The point is that when this is increased there. So for example, it is used to be there in a, one thing is that in your fertilizer it is there. It used to be used in the detergent also. And before you use, and after that this all these things comes into the water body, right? So there are like these algae are there which use this, everyone uses phosphate, this phosphorus, but when there is a nutrient rich in the water body, there is a huge, like this population increases very fast of the algae. So this is called in general algal bloom. Okay, algal bloom. What happens that means that when there is so much algae are there, so algae are there, then a huge algae, these algae are there, algae will start dying also there. So this is a small cycle is there. Then when is it dying there? So first thing is that because there is a huge, this algae is there, so therefore they will start using, they need oxygen also, right? They need oxygen. When they are dying also, therefore for their decompositions, these bacteria, they also need oxygen. This oxygen in the water body comes from where? It comes from the, what is the dissolved oxygen, DO, right? So DO. So DO is there, so if there is depletion in the DO, so therefore the other water, the animals or whatever the other species are there, Therefore, there is a depletion for them also, and it actually affects the ecosystem, right? So eutrophication in general is like it is called the eutrophic lake. Right? It becomes a very shallow lake, the swamp, etc. What you see. So it's like a natural process, of course, because the water that is a stagnant water body, and there is like from the runoff. Right? There will be like a slips, etc. All these things will be there. It will come and gradually it will be becoming like a shallower lake, right? However, and this also there is some nutrients, minerals it will come also. Now the eutrophication is a natural process, but it takes a long time. What is there? Again, the things comes the pollution. Means that because of the human intervention, because of different industrial agent that we are using, that this eutrophication gets accelerated. Okay, fine. So I thought maybe because just again for the relating this all these nutrient parts, I thought maybe I can show it there. But this we will discuss in detail in our water pollution part. Right. So these are, you can see that controlling factors in eutrophication is the eutrophication that production of the algae. So means that algae production you have to control. So therefore one thing is the availability of the sunlight to power photosynthesis and nutrient concentration for growth. Okay, so availability and sunlight is what problem is that when it becomes shallower, so what are the in that there is a availability of sunlight at the depth, it will be lesser and lesser, right? That upper part that becomes actually covered with the algal, all these things. So it becomes lesser, and so whatever these plants were there, which was in depth, which was by photosynthesis used to contribute for the oxygen. One thing is the oxygen income aeration, right? Directly atmosphere. Another is the photosynthesis. But wherever all these plants are there, they are not getting sunlight, they will die, and of course photosynthesis they were able to do it. Other part is that limit the nutrient concentrations, right? So this is called that Levick's law of minimum, means that we have to see that what is the sensitive part, right? So which is it? For example, two part is important, nitrogen and the phosphorus. And you can see that which is more sensitive, means that which one this algae requires very small amount to build up its protein, right? Or increase its population. So that is, you can see that there is a one small example is there, and you can see that limit that part, right? So you can see that this example for the photosynthesis given, there is called the cyanophyta, right? And see this what is forming, this glucose part, what is actually it is forming here. Okay, so here if you see that what is how much N and P is required, that you can see N by P is a 7.2 ratio, means that it needs like a 7.2 times more nitrogen, right, than the phosphorus. Means that it is sensitive to phosphorus, right? It is sensitive. So one like you need like a phosphorus that is mole, 1 mole here, for that it is like a 7.2 mole. So means that in that case, what is called, these are called that it is a phosphorus limited lake. Because of this certain this amount is there, and therefore what we will do, we will try to do, instead of making this nitrogen limited, so what you will do, you can make it like a, try to see what are the sources from where the phosphorus coming into the lake, and cut off this phosphorus, and you can prevent the eutrophication, right? So this is just one example. We are going to come back and many other things, right? Okay, so we'll start with the air pollution part. Right, so of course we have started, we already discussed, so pollutions ultimately, if we go for any definitions of the pollutions, it occurs when substances are released into the environment in harmful amounts as a direct result of human activity, right? So, and you see that this until recently, that's what I have been stressing on, that until recently, however, these changes are represent only a small perturbations in a large system. Therefore, do not care much actually, and have not seriously threatened the homeostatic mechanism, right, called feedback loops, which tend to maintain the system in a stable condition, which is like your running of this all these cycles are there. Okay, but unfortunately, man is capable of inducing large enough perturbations in the ecosystem, which can permanently upset the balanced state of the natural cycle. Okay, right. So I have said that there is the air pollution, I said water pollution, all this, there are pollutants are there because of the human activity. These are polluting your air and the water. And of course, this, what is that? I mean, soil pollution is also there. There are nuclear activities are there, radioactive substances go there, and others it can pollute the soil also. And that's one, the soil pollution, in fact, affects the groundwater pollution. What is the another pollutions? Tell me. Anything else? Any other pollution?
Noise pollution.
Noise pollution. Okay, that's of course it is also affecting
Soil
pollution, sex, soil, water, air. Anything else?
Light pollution.
Huh?
Light pollution, yes sir.
What?
Light pollution.
Light pollution is what?
Nowadays, sir, it used to make because of the sir, always the lights have turned on for in the nights also.
But is it like a related to, you are saying that it is because it is carbon that you want to reduce the carbon emissions for that, no? You are saying that.
No, sir, it is damaging the ecosystem like those organisms in the absence of that.
So there is the other major is that for the thermal pollution, right? So what I of course say, right, increasing the temperature, so kind of like a effect of the air pollution only, right? But your power plants are there. I mean, not like exactly, that is indirectly, that it is a containing heat, increasing the temperature. But directly also you are emitting a loss of heat, right? So instead of what you do in the power plant, right, you can use it. What do you use? The cooling tower. Oh. What do you do? So, what do you do? The cooling tower, right? Cooling tower you use. The cooling tower, so but before that actually, there is a directly this heat was to loaded into the nearby water. So cooling tower is one area is that evaporation of CO2 and it can go to the air. So that also is called that another pollution, thermal pollution. Directly like in the water body you are loading there, and it can affect, of course, there are like in that water body that there are like fishes, etc. These things, and they cannot actually maintain their what is that? They cannot maintain themselves in that temperature, right? That is the average temperature they need. If it is increasing, then right. Other thing is that if you increase the temperature of the water body, there are decomposing bacteria are there, which will be very much active, right? When they are becoming very much active, there are like the organic bodies, etc. there, what they need for their energy consumption, right? So when they have become very active, therefore they also use the dissolved oxygen, okay, and therefore that also becomes like a problem for the depletion of the dissolved oxygen. So that is also effect of the thermal pollution. So the thermal pollution we may not discuss that much, but we understand that is the effect. Anyway. Right, so example of air pollution, we are going to discuss a lot. One thing is that what I would like to stress is there, right? So you have again, air was polluted. When the earth forms, of course, air was polluted, and after that, all these plants, body photosynthesis, etc., comes, and therefore this all these the other species comes into the picture, and after that you can see that yes, this ecosystem has formed. Like okay, but what I was telling that this human contributions encourage changes in recent history, global, they have come relatively quickly compared to the natural rate of change. Okay, right? And Earth and its inhabitants' natural adaptation capabilities might not be adequate to meet this challenge. So what does it mean? Mean that say your evolutionary effect is not adequate to adapt to this change. See, evolution takes like a long time. I mean, you really cannot distinguish that when the ape becomes man, right? So you cannot distinguish it. It's like a long time genetic. But the thing is that it is the change is so fast actually. The rate is so fast that it becomes, we have to term it as a pollution, right? And there is this natural phenomenon that I was talking about, that such as volcanoes, forest fires, and this decaying organic matter contribute substantial amounts of the air pollutants. And that this organic, this differs particles, but this natural pollutions really not that much to change the ecosystem that much. Maybe local, maybe like some, of course, like locally, of course, if the forest fire is that it is destroying them, but globally scale it's not that much. Okay? Right. So, and these are the impact of the, of course, impact of the energy sources on the environment. Right. So first thing, why do we need the energy? So with the your population's growth, you need a energy demand is increasing and increasing, and to run the industrial plant and your automobile, right? You need what are the things you are using? Conventional sources, fossil fuel, renewable sources, and nuclear sources, nuclear power plants are there. Okay. And this energy production and this consumption lead to your air pollution, climate change, water pollution, thermal pollution, and solid waste disposal, which include radioactive waste from the nuclear plant, as well as your renewable sources also, right? Your solar cells, your lithium battery, where does it go there, right? So if it is not recyclable, it is okay, but some parts, all the parts cannot be recyclable. There are e-waste also there, right? So these are the things there are, of course, not that much analysis. Right, so fossil fuel combustion that leads to your air and thermal pollutions. Oil spills are there, which leads to your water pollution. Nuclear is there, and renewables. These are some things we need to, of course, understand that. I mean, we need to be aware of it. That one thing is that your disposal, land use, so land pollutions are there. Because of that, habitat loss could be there. Solar plant, you are actually where you are making the solar plants there. So for that, there could be like a habitat loss. Some water use could be there to forming it there. Use of like a hazardous materials. For example, some new generation solar cell that use like your lead, right? So you need lead actually for that. So that could be like a hazardous waste there, right? And of course it is producing ultimately the solid waste. Completely cannot be recycled, right? Right, so now we will be starting the first part of our this discussion is the air pollution, right? So what are the what are the humans? So as I said, we now completely figure it out. There is a really not that much as a concern about the naturally what is going on there, but the human intervention and the human activities. So therefore, we can see that we can identify what are the primary sources of the air pollutants, right? So one is like after introducing your internal combustion engine, which is used for motor vehicles there, and of course some other things also, and your fuel that is burned at stationary sources like in the power generating plants. There are different industrial processes there, and there could be like some climatic conditions which lead to the air pollutant or the distribution of the air pollutants at some point. So this also we are going to discuss in our course, right? What are the atmospheric conditions, right? What is the on the air pollutants? Right, so now again you see that what I am saying, why it was not taken care until recently. Because the human population was increasing, these things are increasing, therefore our activities were increasing, and therefore after that this effects comes into the picture when there is a large amount of death. right? So takes place on public health even though the technology for controlling pollutants may be available, right? So early recognition of the pollutants and health hazards have not resulted in pollution reduction. Traditionally, only when personal survival at stake, then effective action has been taken, right? Okay, so this book, what I am following, is the Gilbert Masters, right? So Gilbert Masters, you are aware of it? I mean, it is given already that your ERP portal, you can see these names are given, right? And give it a, whenever these things are slides, etc., I will share it. But give it a read. Right, give it a read. But I'm saying that this public out there, all these things I may not be able to discuss it yet, but it is a very good read actually. That you see that how this might, I forgot actually what was there. But there was like, as I said, there is like a health effects is there. Nothing is the awareness is there. Maybe in our country also it was there, but nobody took care. But outside it has been taken care, and this clean air regulation program, all these things that Clean Air Act has come with the picture. So these examples are given, so give it a read. Right, so now the classification of the pollutants. Right, so this is called the primary pollutants and secondary pollutants. Right, so primary pollutants are what is emitted directly into the atmosphere, and secondary pollutants. So primary pollutants that create later the secondary pollutant, like this DOC. So primary pollutants are there that this creation process are combustion, evaporation, grinding, abrasions, right? So when we discuss the criteria pollutants, that time we will discuss that. But you can see that I have written it here. Combustion, you understand that this because of this burning of this fuel. Evaporations directly from the volatile substances, it comes into the air. Grinding, because of this, there are this your different building work, etc. is taking place there. There are materials are there. From there, like a small microparticles, even in the PM level, it can comes into the air, right? And these abrasions like asbestos filter, I mean directly like you don't have to do that grinding, but from there naturally when it is there, these abrasions takes place. So that this one will be like an example of this primary pollutants, combustion of the pure hydrocarbon fuel. So there are many other components are there, but I am considering here this CH4 is there, and you can see that from their burning, this CO2 H2 is there, but there is a complete burning is not possible. Right? So always like there will be incomplete burning. So, I mean, because you have to run your cycle, so full complete burning, that time may not be available, but of course you can improve your technology for your complete burning. That is another thing is that change the fuel itself. So that is different. So that actually comes into the, for example, you see that is U1HC, that it is coming there, and this both are having like it can have adverse health effects on human body, right? Similarly, for this NOx, you see that there is in your combustion engine that heat is produced there, right? And therefore this it's called the thermal NOx actually, not the fuel NOx there. So this this N2O2 is there, and because of the heat this NOx that is actually forming there. Okay. Right, so considering the pollutants, I mean first identify it and you see that how it is actually affecting them, and see that which has the most adverse health effects, and that is how, I mean that's how we have to have your policies, have your technology, form your technology so that you can mitigate this, right? So that is how this first thing is that identify your problems. So that is how criteria pollutants comes into the picture. So what are the criteria pollutants? There is carbon monoxide, sulfur dioxide, nitrogen dioxide, ground level ozone are there, and this particulate matters there, and another is like a lead pollution, which more or less we have having here has been reduced, right? And these are the type of source of air pollutants I discussed. Right? I mean, first the criteria pollutants and where it is coming from. So mobile sources are there, and these are the stationary sources. Okay. So from here, we'll next class we will start discussing. Okay. So first the criteria pollution. What are the things? What are the properties are there? What is the effect of it there? All the things. Then we will go to the next part. Is that what are the sources? When we discuss the sources, we will be discussing mostly that what are the technologies that can be implemented to mitigate this. So that part indirectly. That is how our course will go. Okay. Then we will go that your atmospheric conditions. D1, D5, D50, Archie, Saloni,
Yes, sir.
Naina, Bharti, Prabhakar, Rachit,
Yes, sir.
Anushka,
Yes, sir.
Dipanjan, Jaya, Vinay, Vikas, Ritu, Seguravan, Mukta, Sailesh, Shurajit, Harshit,
Yes, sir.
Shashank, our high Vinil,
Yes, sir.
Ankit,
Yes, sir.
Anushka,
Yes, sir.
Ayush,
Yes, sir.
Banwari,
Yes, sir.
Daniel,
Yes, sir.
Rishik,
Yes, sir.
Aditya, Aniket, Harshit,
Yes, sir.
Raghunath,
Yes, sir.
Vishal,
Yes, sir.
Deepika,
Yes, sir.
Divyanshu, Khushbu, Saurabh,
Yes, sir.
Narendra, Punit,
Yes, sir.
Shivam,
Yes, sir.
Kamlesh,
Yes, sir.
Sanitya,
Yes, sir.
Rohit,
Present, sir.
Naval, Shashwat,
Present, sir.
Yashasvi, Hamlet, Mohit, Tushar,
Present.
thank you.
Yeah, there's a class. Look on the strong class. There's a class.
So